Hello everyone, welcome to my channel. Myself Gadak Dhanashri. Today we will discuss congruence modulo n. Let us see definition of congruence modulo n. Let a and b be any two integers, n greater than 1, be an integer. If n divides a minus b, we say that a is congruent to b modulo n. A is congruent to b modulo n. Clearly this defines a relation in the set of integer is called congruence relation modulo n. Thus, a congruence to b modulo n implies n divides a minus b, implies a minus b is equal to nk for some k belongs to z. For example, 5 congruence to 11 mod 6. Since 5 minus 11 means minus 6 is divisible by 6. Next, properties of the congruence relation. Theorem, let a, b, c, d, x, y is an integer. If a congruence to b modulo n, then we have to prove that x congruence to bx modulo n. Second, a plus x congruence to b plus x modulo n. Let us prove that given a congruence to b modulo n by using definition of congruence implies n divides a minus b, means a minus b is equal to nk for some k belongs to z. We have to prove that x congruence to bx modulo n, that is x minus bx is divisible by n. Now consider x minus bx is equal to, taking x common, we get a minus b into x is equal to a minus b is equal to nk. From first, a minus b is equal to nk, n divides a minus b, a congruence to b modulo n. So a minus b into nk, see here. So by implies n divides a minus b means x minus bx by using definition of congruence. So ax congruence to bx modulo n. Second, we have to prove that a plus x congruence to b plus x modulo n, that is a plus x minus in bracket b plus x is divisible by n. So now consider a plus x minus in bracket b plus x. We have to solve this bracket. We get a plus x minus bx minus x. So a minus b plus x minus x get cancelled. So value of a minus b is equal to nk. From first, given a congruence to b modulo n, so n divides a minus b and a minus b is equal to nk. So this is by using definition of congruence. So we get n divides a plus x minus in bracket b plus x, that is a plus x congruence to b plus x modulo m. Hence proof. Second, if a congruence to b modulo n and c congruence to d modulo n, we have to prove that a plus c congruence to b plus d modulo n. Second, we have to prove that ax plus cy congruence to bx plus dy modulo n. Third, ac congruence to bd modulo n. So given a congruence to b modulo n by using definition of congruence modulo n means implies n divides a minus b is equal to nk1 for some k1 belongs to integer. Second, c congruence to d modulo n implies n divides c minus d, implies c minus d is equal to nk2 for some k2 belongs to z. We have to prove that a plus c congruence to b plus d modulo n, that is a plus c minus in bracket b plus d is divisible by n. Consider a plus c minus b plus d is equal to, we have to solve this bracket. We get a plus c minus b minus d. So written as a minus b plus c minus d. So value of a minus b is nk1, value of c minus d is nk2 from first and second. So taking n common, so we get n into k plus k2, means by using definition of congruence A minus B is equal to nk, A minus B is equal to nk, means n divides A minus B, means n divides A plus C minus in bracket B plus D, means A plus C congruence to B plus D modulo n. Second, we have to prove that x plus cy congruence to bx plus dy modulo n. That is, we have to prove that x plus cy minus bx plus dy is divisible by n. So consider x plus cy minus bx plus dy can be written x plus cy minus bx minus dy. So written as x minus bx taking x common, cy minus dy taking y common. So value of a minus b is nk1, value of c minus d is nk2 from first and second. Taking n common, we get n into k1 x plus k2 y. So by using definition of congruence, a minus b is equal to nk, means n divides a minus b, means n divides a minus b, means n divides x plus cy minus in bracket bx plus dy. So n divides a minus b implies a congruence to b modulo n, means x plus cy congruence to bx plus dy modulo n. Next we have to prove that AC congruence to BD modulo n. That is, we have to prove that AC minus BD is divisible by n. So consider AC minus BD. So we can write AC minus BC plus BC minus BD. Adjust this term. So minus plus get cancelled. We get previous term. So taking C common, so we get A minus B into C, plus taking B common, we get C minus D into B. So value of A minus B is nk1 into C, plus value of C minus D into nk2 into B. Taking n common, we get n into k1 C plus B k2. So by using definition of congruence, a minus b is equal to nk, means n divides a minus b, means n divides AC minus BD. N divides a minus b means a congruence to b modulo n, means AC congruence to BD modulo n. Thank you.